Hey everyone, this is Matt with Learn Everything About Design, and in today's episode, this is episode 6 of our GPZ build series, we're going to walk through the process of modeling the shock clamp. So this clamp here is basically a simple 3D printed part. We could machine it, we could do all kinds of different fabrication techniques, and in the past I actually did machine something similar to this that worked with the stock subframe size. This one, because I'm running 1/2 inch DOM tube, really means that we need to have a different clamp system. There's just not, the tubing is not there anymore for what it used to be. So this part is very specific to this bike, but if you want to kind of go through the process of designing simple parts like this, and I consider this a simple part because it just uses basic prismatic features. There's nothing really magical about the geometry, like doing a headlight mask or a fender or a fairing or something like that. So the first thing that we need to do with this process is measure. We've got two main bits that we need to attach to. We need to clamp around the shock reservoir, and we need to clamp onto the DOM tubing. Now, when we're considering the sort of distance or the spacing here, we also need to think about the fact that this needs to flex and clamshell open. It doesn't have to flex that much, but it does need to flex enough so that we can get around that DOM tubing, which is roughly 20 millimeters, somewhere around there. But the first step of that process is, again, just to kind of measure what we have and the space that we're working with. You don't need a 3D scanner for this or any fancy tools. Really, we just need a set of calipers so that we can measure the outside diameters, and then just a piece of paper to mark some notes and kind of give a rough idea of what things like this look like. Now, when I go into the process of designing parts like this, sometimes I have an idea in my head what I want it to look like, but generally what I do is I build out where the sort of constraints are, the two tubes or the shock reservoir and the tube, and then I kind of see what shapes kind of come out of that. So a lot of cases you can pre-plan this stuff. In some cases you just kind of flow with the design. But once we have all the measurements, then we just simply take that back to a desk or laptop if you're in a garage and do that, and start to model in Fusion. So let's go ahead and hop into Fusion and start building out this part.
All right, so now that we've got some basic measurements, we can get started modeling something. And it's important that we understand, or we have a rough idea what we want to build. If not, we can do some shape exploration, but really the first starting point is to add some circles for what we measured. So the shock reservoir was 54 millimeters. And the actual subframe that I built, which is still just tack welded, it's 1/2 inch DOM. So it was about 20 millimeters, but the actual measurement was 19.36. So I'm going to use the actual numbers, and maybe, I mean, it wouldn't hurt to make them just slightly bigger as long as it's enough that it can be clamped down. So if we did, let's say 54.4, and if we went up to maybe 19.8 and still had a little bit of room that we could clamp it down. We're going to make the small circle vertical with the large circle so the shock reservoir could just hang down. And then I will use a dimension to go from here to here. And let's see what it looks like at 40. So these two could theoretically touch, but I do want some material between them. So I'm going to make it a bit bigger. We have to decide how it's going to get clamped together. That's going to be a big thing. And if there's going to be, let's say, a bolt between here. Now, the shock reservoir itself could slide into this bracket from the outside. So having a gap in the middle would be just fine. So for example, I'm not going to dimension this, but for example, if we were to have this as an opening, and let's say that we just had larger circles here, and we connected them with lines. We'll do the same thing over here. Again, so this part right now is just doing some concepting and working out the shapes. But essentially, what we would have is this setup here where it has a gap between it. And then we could run a bolt through here, put a nut on the right side and just clearance for the head on the left side. And that would be able to sort of cinch both pieces down at the same time. The problem with this is that we actually can't do this because we need it to completely come apart, or at least have a split here so that we could stretch it over the DOM tube, because the subframe doesn't come apart Even though the shot can slide in from the side, the outside piece does not come apart. So as I'm looking at this, what I kind of see, or what I envision here, is that this split stays, and I put a bolt through here to clamp that down. And this gets split open as well. And this would allow me to essentially stretch the whole thing open just enough to get it onto the subframe and then clamp it down. So that means that there could be a bolt on the outside for security reasons, just to hold it all together, or we could run it in a minimal setup and try to clamp it here. So either way, this looks like it's probably a good start. And I'm going to dimension what I have here. So let's say 64 maybe. We don't want it to be too thin. And let's say 30. That looks okay. And then we'll just add some dimensions here. Looks like 3 millimeters on one side. We'll make this 3 on the other. So, full disclosure, I have built a shot clamp for this before, and I think I mentioned it earlier on. It was a bit different because it was the original subframe tubing, which was quite a bit bigger. And I did a split clamp system. So the part where it attached to the frame, there was basically two screws coming in vertically. So, one this way and one this way to kind of clamp it all together. That worked okay for that setup. This setup is going to be a bit different. We could theoretically split the entire thing down the middle as a clamshell, and that way there would be a screw on the outside here and a screw on this side, and then maybe not have a gap in the middle. But as you're designing parts like this, as you're coming up with these concepts, it's a good idea to just play around. See, kind of see what works visually, what works for you, and then make adjustments there. There's no reason that we have to be fixed to anything. So I'm going to go ahead and make these collinear, keep those gaps the same. And then as I'm looking at this, the last thing I want to do is I want to make sure that I can fit. So I'm going to run 8 millimeter bolts or screws. So I want to make sure that I have enough room for that. So the hole is going to be 8 1/4, so passing. And we can see that that just won't work. The screw itself is going to overlap, which tells me that this value here needs to be a bit bigger if I want to put a screw or run that size screw between them. So if I take it up to 50, that is going to leave me enough material on either side that the screw would fit through there. So again, that was just kind of a placeholder just to make sure that it was okay. And I'm going to run with that. The last thing I really need is some more material on the outside for a shorter screw. So I've got 2 8 millimeter sort of socket head screws that I'm going to use. One is going to be about 18 millimeters long. The other is about 25. So the longer one would go in here. So that means that I want to build out a section on the outside. It needs to be large enough for the nut, and the nut is 13.5 across. So if I give this a dimension, right now that's not quite big enough, so it needs to be probably 15. And then it needs to be at least, so the overall length needs to be, at least about 20 millimeters. It could be a little bit longer. We could make it 22. And then I will just make sure that this is this value divided by 2. That way it's perfectly centered. So using this measurement. So that way if I change this to 24, it's always going to stay centered. And 24, that's a good number. We'll go ahead and stick with that. So this is 15. Let's go ahead and pull this down here. And these don't need to be that high up. We'll go ahead and pull those down. So this is 15, and the nut is going to be, the nut's going to be 13.5, and it's going to have material on either side of it. So if we're looking at something like this, this is going to be the sort of width of the nut if we're looking at it from coming at the X direction. So if we're kind of piecing this together, that doesn't really look like enough material, because if we go from the midpoint of this out, and then we take this and do an offset in both directions, the diameter again is 8 1/4, so 4.125. this is basically what we're looking at for like the head of a bolt and the bolt itself coming through here. I know this is really hard to visualize, but just kind of keeping in mind that that is gonna be pretty tight. Not really enough room to make that work. So I think this is gonna have to grow, unfortunately. So that way this can come up. And that looks like we probably have enough room now. The bolt, so the actual frame is going to be in here, so this could be a bit lower, and it's perfectly fine as long as we have enough material there. So I'm going to go to 18. I think 18 is okay. I don't want to make this too big. And I don't need this, and I don't need this, or this, or this. They were just kind of temporary. These lines do need to extend because this is going to be split. So I'll just carry those up. Make sure, it looks like I got a little extra line in there. Go ahead and make sure that that goes all the way. And so now this is going to be open, and this will be open. There won't be any hardware down here. It'll be clamped together in the middle, and it'll be clamped together on the outside. So once again, I'm going to just pull this through just to make sure. So 8 1/4 is the diameter of our bolt. And then we'll do the head here is going to be 13 1/2. And in order to get those together, I'm going to use a sketch point. We'll toss that in there. And then we'll say that sketch point and this midpoint will go together. So kind of locks it in. All right, so this one, this right here represents the height of the nut, and it's going to be at least 20 millimeters. Let's say 22. So that's where the nut's going to sit. That's where the screw's going to sit, and I think that's fine. I think we got plenty of room there. So again, those are just temporary. I just wanted to kind of see what kind of space I was working with, and that point can go away too. All right, so now that we got this sketched, all that was just to kind of build out the concept. We are going to extrude it, and this, again, we need to think about how wide it needs to be. So I'm going to do symmetric, and I think making it 1 inch, so 25, I think making it 1 inch, probably okay. Yeah, so some of this stuff is going to get rounded off. I don't really need to do fillets just yet. We'll do those at the end. This section up here, I'm going to do a quick measurement. So let's go from here to here. That's 24. And the height of the nut is 6 1/2. So that's going to leave me with, if I measure this, that is 9 millimeters. So if the nut is completely sunken into the plastic, then that's only really going to leave me 2.5 millimeters, which is not very much for this thing to be, tightened and pulled on. So what I'll probably end up doing is raise a section up on this side where the nut goes, rather than make the whole thing thicker, because it's just going to add extra material. This is going to be 3D printed. I'm not going to worry about machining this, but we certainly could downstream if we wanted to. But what I want to do is go ahead and add that in there. So we'll create a sketch. We should have the middle of this, so we can just use a line from midpoint to midpoint, turn it into construction with X, and then C on the keyboard for circle. And let's go ahead and make it 15. And then I'm going to go to create polygon. And in the center of this, I'm just going to place the polygon, make the top horizontal, and then dimension it from top to bottom. And the size of the nut is 13.5. All right, so you can kind of see what we're working with here. 15 is not quite big enough. So if we go to 18, it's starting to overlap here. And so what this tells me is we've got more room down, that we can go down a bit further. So probably tells me that I don't need or want to go in the midpoint of this. So what I'm going to do is get rid of that midpoint constraint, and then I can pull both of these down. and give them a dimension to the top. So that way I can move it around. So we'll go ahead with 10.5 and make sure that it's coincident with this line. So we're going to extrude this out, make sure you get all of those regions, and we'll join it together. So I'm going to add 3 millimeters. That's going to give me 3 millimeters on the outside, and then that gives me 3.5 that I need to sink it in. So we can take this face, extrude, and we'll do minus 3.5. So now the nut should be able to just drop into there, and we can do a fillet around the outside. So let's go ahead and blend that in. 2 millimeters should be fine. While I'm at it, I'll go ahead and add it to the other side. All right. And then in the center of this, I'm going to go ahead and create the sketch. It's not going to give me a center point because it's not a circle, but we could go back to that last sketch. So this one here, and project that point. So that's the shortcut key P on the keyboard. And then the diameter that we want for the passing hole. So it's an 8 millimeter bolt, 8.25 on a 3D printed part. Should be tight enough. And then extrude it. We'll go all the way through this way. And the last thing that we would need to decide is, do we want the head of the screw that's on this side to be sunken in at all? So it can just rest on the outside, but the distance, let's go ahead and measure this. So the distance from, not from there, the distance from here, no, let's do this. The distance from that face to this face is 20.5. The distance that I measured when the nut has full engagement on the bolt is 18 millimeters. So I could take out 2.5 millimeters from this side, and because the bolt that I'm using in this position is actually a button head and not a socket head, it's pretty minimal. So that would allow it to sink in pretty well. So what I'm going to do is create a sketch here. We'll do a circle, and the head size, again, is going to be about 14 millimeters would give us enough. You can see that goes just up to that fillet. Now 14 millimeters is actually a bit more than I need. So if I want to stick to that fillet, what I can do is convert this dimension to a driven dimension and then make it tangent with that edge. So we're not extending past that fillet. 13.7 is going to be plenty fine for the bolt that's going in here. 14 is probably quite a bit big for what we need. So then we can take that minus 2.5. It gets us right to our 18 millimeters from the face where the nut is to the face where the back of that bolt is. All right, so that's the first bolt. The second bolt is a little bit trickier. And what I want to do is I want to start by extruding first. So the other one's going to be a bit longer. It needs to be about, I'd say 24 millimeters. The overall length from the bottom of the head to, I guess, the longest position where the nut would go is going to be about 30 millimeters. And then the overall length is going to be plus the nut, so 36.5. So as we're looking at this, what I want to do is either create a plane where I want the head of that bolt to be, or I want to just start to create the geometry. So I'm going to start here, and I'm going to go ahead and pull a plane back, let's say 12 millimeters. And I'm going to make that bigger so I can click it easier. And we want to have it positioned in the center. So generally what I'm going to do is create a line here. That line is going to be construction, so X on the keyboard. And then I'm going to project this face, so P on the keyboard to project that entire face. And double click. And what this does, it gives me a reference here. So I could actually just take this line. This is going to be hard to see. I'm going to hide the bodies for now. I could just take the line and go midpoint to midpoint, and then do a circle here. So again, the circle is going to represent the diameter of the bolt. So 8.25 is passing. The hex we'll do with a polygon, and we'll just place it in there. Make sure that it's horizontal or vertical. And then the amount it needs to be to fit is 13.5. That gives it plenty of clearance. So if we bring the bodies back, that's the size of the hex of the nut. And the total height again is 6.5. So what I want to do is I want to take that and I'm going to extrude it. I'll hold down left mouse button to get that profile. I'm going to get this one as well. And I want to come out minus 6.5. And note that this means it's sticking out from here. So the shortest distance that I could possibly go without it sticking out is about 4.5, which means that I need to go the other direction. This needs to go in 2 millimeters. So 2 millimeters there, 4.5 here would give me the total height of the nut. I want to make sure that it's in there. So I'm going to pull that all the way out. But now we know basically the distance that we had to go. We'll say okay. And we'll grab the sketch. We're going to take that and we're going to extrude it all the way through. We'll just say through all. And then we'll hide the sketch for right now. So now what we want to figure out is where the head of the bolt needs to be. I'm going to work backwards by creating a plane. Now I know that underneath the, from the underside where the head of the bolt is to the underside of the nut is about 30 millimeters. So if I go this direction, minus 30, that is where the underside of the head is going to be. Now we could actually consider, because the nut is on a slanted face here, the threads can extrude or stick out a little bit further, but 30 is roughly where it wants to be. So then what I'm going to do is create a sketch on this plane. I have this as a reference, but I'm going to rotate this around and grab the edge that's on a planar face, and we'll project that. And then we'll create a circle that is going to be clearance for the head diameter, so 14 millimeters. And then we'll hold down the left mouse button to extrude that all the way out. So now that gives the position where the other bolt is going to be. Again, if we want it to be completely encompassed, we could change the shape of this. I could also use a button head instead of a socket head here. Just kind of the hardware I've got laying around is what I'm measuring. So a socket head cap screw could go in this position and the button head could go up there. I could always switch it out later if I needed, but this gives me a good starting point. Now, if I want to change this, all I need to do is redefine the plane. So instead of minus 30, let's say we went minus 28, and that'll just change the orientation of that plane because we did extrude all or through all. So we don't have to go back and change the extrude height or anything like that. The last couple things that we want to do here is we're going to round off some corners. These ones can be chamfered. It's probably better if we chamfer those. Then I want to round off some of these other corners. And the sort of last consideration that we have here is whether or not this is going to break, if it's going to be able to flex enough and work. And I don't really know that until we try it. I can use the PLA-CF material or PETG or something that's a bit stronger than just a basic PLA. But what we have to consider is that the PLA will actually flex quite a bit before it breaks. But something that's stiffer, like a PLA-CF, is going to be more rigid, which means it's not going to want to flex and it's more likely to fail. So for something like this, I might actually just run Hyper PLA, at least to try it out and see if it works. But let's go ahead and do a couple of chamfers on these edges here and on the leading edge, because we're going to have to flex this thing in. 1 millimeter should be fine. Actually, let's do this one. I missed that one here as well. We'll do all those. And we can add to it if we want to. Because these are all at 45 degrees, they should print just fine. So if you're 3D printing, it tends to be fine with 45 degrees. Most printers now go up to about 50 degrees without needing support. So that looks okay. I'm going to try to do a fillet on these edges and see what it looks like. Just bring it down to just before that. And we'll hold down Control and get there. That looks okay. And then I'll do another chamfer on the outside. I'm going to go a bit bigger, 2 millimeters on the outside, just sort of for looks. And then if we want to, we can clean up some of this stuff. You can, if you're 3D printing, the chamfers tend to do a bit better, but keep in mind that this thing is going to be printed in this orientation. So it's going to be printing vertically, and these holes are likely going to want some support in the upper section, or we're just going to kind of run with it and see how it works. On the nut side, I don't really want to do any treatment. I may add a small fillet here and just kind of round it off, maybe 0.5. And this one here, God, it's tricky. I'm going to go ahead and then just chamfer all. Actually, you know what? I'm going to do a small fillet on all these corners because the opening is a little bit larger than the nut, and let's see if 1 millimeter would be okay. And then I can just do a single chamfer on the outside. Yeah. All right, looks pretty good. All right, I haven't saved this thing at all. Hopefully you guys are better at saving than I am. We'll come into our GPZ series. Where is it? There it is. And shot clamp. All right, and then we will name the body GPZ shot clamp. Save it one more time, and then send this off to the print slicer. So STL, Bambu, there we go. All right, so in terms of print orientation, probably best to just slap it on a plate like that. We do want to consider the strength. If you want to print this as a solid, it's going to take quite a bit more time. So if I say 100% and slice it, it'll print it as a complete solid, and looks like it's going to take almost 3 hours. But as we go down through, everything on the inside is going to be solid. Now, do we need to do this for a test? No, we certainly don't. So if I set this to, let's just say 25% and slice it. So instead of 2 hours, 40 minutes, we're looking at 1.5 hours. So that certainly saves us enough time. And with a 25% infill, the part will still be pretty strong. But I would suggest increasing the wall loops so that way we've got a bit more strength around where it's compressing, especially those bolt holes, and potentially changing the infill pattern to something like a gyroid. Yeah, let's go ahead and see with a couple extra traces what this is going to do for our time, and added about 20 minutes to it. So instead of 1:25, 1:55. But the infill is going to be stronger for us, and adding those extra walls, we can see on the clamping area that we've got 3 on the inside and the outside, so they're relatively close. That is still going to have some infill, and that's potentially where it's going to fail when we sort of stretch this thing open. But I think I'm going to run with maybe a little bit more, 35%, regenerate it. So that's a bit denser. If we go down through the part, yeah, you know what? 2 hours and 14 minutes. When we go to 100%, it's not that different. So going from 2 hours and 14 minutes at 35% infill to 2 hours and 40 minutes to make it solid. I think I'm just going to make it solid. And again, I'm going to use Hyper PLA first. This is going to make sure that everything works okay. If I find that it's not strong enough, then I probably will do a PLA-CF and give that a shot. But let's go ahead and send this off to the printer, and then we'll check back in once it's done.
All right, so now that we modeled the part and printed it, after I printed and put this on the bike, I ended up making some modifications. I made some changes, I improved the part. The first thing I did was I printed this in PLA-CF. So I had a version of the Hyper PLA and a version of PLA-CF, just because the PLA-CF has better temperature resistance, it's got better mechanical properties. And after I kind of held these in my hand, I thought to myself, they're just too heavy. There's more material than there really needs to be inside this part. So then I went about creating new variations of it, just removing material where it didn't need to be. Now, because the main function of this is to clamp onto two tubes, essentially, really the bulk of the material needs to be where the bolts are, right in the middle. Everything outside of that is just going to be extra surface area, which is going to help us. So what I did was I removed material on either side of those bolts, and then I just left a bit of material on the outside for strength. So I printed it in the Hyper PLA, the basic stuff. And then once I was happy with the design, I made a few more tweaks and changes. I tapered some of the walls inside so I didn't have to run supports in there. And I went ahead and printed the final version out of PLA-CF. So this gives me a final end-use part that I can use. I'm going to run with this, this PLA-CF printed part. It's printed with 100% infill, so it is solid, but we manually removed all the extra areas where we didn't want that material. So this part should be good to go as is. If we ever have any problems, we can always print it in a different material, or we can outsource it to someone like PCBWay and get them to CNC machine us a final part from something like an ABS material or even an aluminum. But keep in mind that if we go with another material like a metal or an aluminum, that it's not going to be able to flex to get over that DOM tubing, that subframe that I built. So it would really need to have a different mechanism, either be clamshelled with a pivot point, or it actually needs to be two separate pieces, which you could do with this piece by cutting it in half, and it would still be able to clamp the tube and the reservoir by using both of these bolts, and it would probably work just fine that way. But it's always a good idea to do some testing with things like 3D prints before committing to putting a part in metal like this, especially if you're only making one of them and you don't have access to machines. So if you have any questions on this, please leave a comment and let us know. And if you want to see more of this series or anything else we cover on the channel, you can subscribe to the channel and you'll be updated with every new episode of this and all the other stuff we put up. The next episode is going to be the GPS Speedo. So this shock clamp part kind of came out of nowhere. I knew I had to build one, but I didn't plan on doing an episode on it. But I thought it was an interesting enough part that we did that. So the next one that we're going to be doing is taking a look at doing some electronics. It's going to involve scanning the pod that's on the tank now, recreating it, create a new version that looks very similar, but it incorporates the Nexion display that I have and all the electronics. I'm not going to worry too much about making it waterproof for the first version. Just want to get something working. This is going to be a fair weather bike. It's not going to be something I would commute in all weather. So I'm not too worried about it being waterproof. So we're just going to go ahead and run with some basics, making sure that it works and build it out. And then we'll go from there on what a final version looks like. So once again, any questions or comments, leave them below. As always, thanks for watching. We'll see you in the next one.